problem says, write the ground state electron configuration now with a noble gas core of helium, neon, etc. And for an atom of chromium. Now, I've chosen this one particularly because there are a couple things up with it, but we always start by going to the chromium atom on the periodic table. We see it's got 24 as its number of protons. It's an atom, so it must have 24 electrons. And we start this by coming up to the begin. Oh, so, right, this is a noble gas core. So how we actually do this is we go to chromium, we go backwards on the periodic table until we get to the last noble gas, which is argon, and we put argon's chemical symbol, Ar, in parentheses. And so that means that that's shorthand for the first 18 electrons of argon. And so then we go here to 4s, and there are 2 electrons, and then we go to 3d, 1, 2, 3, 4, and we're not done yet because chromium is an exception. And what I call it is it's an exception to the shape of the periodic table rule. For electron configurations. And what I mean by that, and this was going over in the lecture outlines, is that because the 4 here, so, well, let me backtrack for a minute. So D sublevels have 5 orbitals. And D sublevels can be slightly lower in energy if there's 1 electron in each of them. So D sublevels have 5 orbitals and are slightly lower in energy. If each orbital has 1 electron. And so in order to get to the correct order for correct electron configuration for chromium, you actually have to move 1 electron from the 4s over to the 3d, and your final answer will be argon 4s1 3d5. So I'm just going to write final correct answer. Argon 4s1 3d5. That's why it's an exception. And there are 5 exceptions that you have to know. And there are actually more exceptions on the periodic table, but these are the only exceptions you have to know. They are chromium, molybdenum, and what are called the coinage metals, copper, silver, gold, because that's what typically gets made into coins. We've seen that argon, what its exception looks like. Then molybdenum is directly under chromium, and the same thing happens. you can see it's the fourth element, but it actually has 5 electrons in this D sublevel. Let me go ahead and go backwards from molybdenum to krypton. So there's the noble gas core for krypton. Then we're actually, after krypton, we go down to number 37. We're in the 5s area. So it's actually going to be 5s1. 4d5. So because this up here is 3d, then 4d, then 5d, and 6d. And I'll just do one of the coinage metals because they'll all follow the same pattern. So for copper, go backwards to argon. Except that now it's a totally filled 3D. That is slightly lower in energy. So the same kind of thing happens for silver and gold. So the D sublevel is totally filled. The S sublevel has 1 electron in it. Are there any questions about this?